Thank you. Thank you. Let me get the first slide. Good morning or good afternoon, good evening, depending on where you are, and welcome back, everyone. It's great to see you all after a break. Hope you are having a great summer. The topic of today's practice session is the automobile industry, and so my speech is going to be about electric vehicles, or more specifically about EV batteries. It is predicted that the number of electric vehicles on the road will increase exponentially in just a few years. According to Bloomberg, by 2030, only in the US, more than 50% of all new cars will be electric vehicles. One reason electric vehicles have become so popular is because they're environmentally friendly, or at least this is the main selling point. Regular vehicles have an internal combustion engine, which is powered by the lead-acid battery and runs on gasoline. In contrast, electric vehicles are powered by lithium-ion batteries. So there is no fossil fuel, no air pollution, no fumes, which is great. But is it actually true that these batteries pose no environmental risk? Well, we'll see. But first, let me briefly describe what a lithium-ion battery is and how it is used. Research on lithium-ion batteries was first published in the 70s, and then the first commercial battery became available in 1991. Now, I'm showing you this diagram here, but don't be alarmed. I am not going to discuss the components of the battery in detail or how it works or why these batteries are called lithium-ion batteries, because this would make my presentation way too technical and there's simply not enough time for it. But I will say that in addition to lithium, they also use raw materials such as cobalt, aluminum, and nickel, among other minerals. This becomes relevant later on when I talk about manufacturing and recycling. Let me switch to the next slide. So a lithium-ion battery is the same type of battery that powers common electronic devices such as your cell phone or laptop, except as you can see in this picture, they're much bigger in size. So the battery is located underneath the vehicle floor between the front and rear wheels. These batteries are referred to as packs because they consist of several battery modules. So you can see on the right, there are 8 modules. And in some cases, those modules contain hundreds of individual cylindrical battery cells that are the same shape as regular AA or AAA batteries. Just a second. Technology. Okay. So the capacity of a battery pack is measured in kilowatt hours, and it varies greatly depending on the vehicle between 30 and 200 kilowatts. So you can see there is quite a bit of range. Lithium-ion batteries have a much higher energy density than the lead-acid batteries in the internal combustion engine. This means that they can store more energy per given weight. And this in turn means that you can get more driving out of your electric vehicle. But interestingly, the driving range varies greatly among different EVs, as opposed to conventional vehicles where you can cover more or less the same distance on a full tank. Okay, next slide. Okay. So the question is how much it costs to replace your battery. Now, the thing is, it also varies greatly. To replace the whole battery costs approximately between $5,000 and $15,000, which is comparable to replacing an engine in a conventional car. But you can also replace individual modules rather than replacing the entire battery pack. So in replacing an individual module can cost you between $1,000 and $3,000. Now, of course, the interesting question, we know that those batteries, just like batteries in your electronics, can be recharged. So how do we do that? the interesting thing here is, again, this varies greatly among different electric vehicles, and also recharging your battery is not as simple as plugging in your laptop or a cell phone. So first of all, it takes much longer to charge a car battery than to fill your car with gas, which only takes a few minutes. So we all know at a gas station, to go from 0 to a full tank, it takes us a few minutes. Plus, here there are also different options. How long it takes to charge depends on the size of your vehicle, the speed of the charger that you're using, and the battery state of charge at the time of plug-in. So basically, there are 3 different rates an electric vehicle can be charged at. At level 1, you have a regular charging cord that goes into a regular 120-volt household outlet, the same outlet used to plug in your electronics. If the battery is almost empty, it will take more than 2 days to recharge. This is quite a difference compared to a few minutes at the gas station, right? And this is, of course, this is the cheapest option. Now, the second level, to get there, you need to install a special home charger with 240 volts and a special outlet for it. So you can see here in the picture, you can install this device on the wall of your garage, for example. Now, this charger and the special outlet for it also, they both cost money, which will be in addition to your electricity bill. Now, these level 2 chargers are also available at public charging stations. And finally, there is a level 3. Level 3 is the most expensive way to charge. It requires a direct current fast charging station, or a DC charger. So you can see here in the pictures, it looks a bit like what you find at a gas, like a gas pump. These chargers are only available at public stations. And using such a device, it takes between 15 and 30 minutes to charge a vehicle. Okay, so as I said at the beginning, electric vehicles are being sold literally and figuratively as super environmentally friendly. So let us look at what it takes to manufacture and then recycle a lithium-ion battery. First, if batteries end up in a landfill, there is a risk that materials and other hazardous metals and other hazardous materials would leak into the soil and water, and that's why recycling is important. But also mining and refining raw materials aren't environmentally friendly. For example, to produce 1 ton of lithium, which is sufficient to make about 100 EV batteries, one needs to use 2 million tons of water. As a result, some South American countries, and as you probably know, that's where most lithium reserves are found, such as Chile, have faced water shortages. Another South American country, Bolivia, is home to the world's largest lithium reserve. I'm sure you've all heard about Salar de Uyuni. I hope I'm pronouncing it correctly. This is the world's largest salt flat. A couple of years ago, the Bolivian government signed a deal with China that allows several Chinese companies to explore the lithium deposits underneath the salt flat. In addition to a number of political and regulatory complications around the deal that I'm not going to go into, environmental activists and experts are concerned that the deal would have serious consequences for Bolivia's environment, but also for the rights of indigenous people who live in the area and for whom the salt flats have traditionally been a source of income. The so-called soleras, who collect the salt from the salt flat and then pass it on to processing plants. And finally, the biggest problem of all, even if we manage to solve all other issues, there remains one big problem. Just as with fossil fuel, raw material deposits in the world are not bottomless. And in a few years' time, humanity may find itself facing the exact same issues as it is facing now. So this is as far as environmental risks are concerned, but there are also other problems when it comes to manufacturing. From the ethics standpoint, a large portion of raw materials is mined in countries with poor human rights record. For example, 70% of the world's cobalt comes from the Democratic Republic of Congo, which is known for its severe human rights violations, including child labor and mining operations. Furthermore, as the popularity of electric vehicles increases, so is the demand for lithium-ion batteries, which in turn drives up the prices for the raw materials. Besides, the prices can also go up due to various political events and supply chain disruptions. For example, following COVID lockdowns and Russia's full-scale invasion of Ukraine, the price of nickel skyrocketed. In fact, according to the International Energy Agency, the extremely high prices for some raw materials are the main obstacle to maintaining EV sales. Now let us look at recycling challenging. So for all those reasons, it would be highly desirable to recycle lithium-ion batteries once they reach the end of their life cycle. However, even though the manufacturers are collaborating with recycling companies, recycling lithium-ion batteries is not that simple. And here is why. There are three main approaches that are currently in use: pyrometallurgy, hydrometallurgy, and direct recycling. And unfortunately, not a single one of them yields satisfactory results. In the pyrometallurgy method, the battery is crushed and shredded, and then it is exposed to extreme heat to smelt the metals into an assortment of alloys. This method is very energy consuming, and it's also environmentally unsafe, as it emits pollutants into the air, including CO2. Another problem with this method is that some raw materials, such as lithium and aluminum, are lost in the process. Now, the second method, hydrometallurgy, it requires the batteries to be soaked in strong acid to extract metals. This method allows to recover more materials compared to the pyrometallurgy method. And it also requires less energy and produces fewer greenhouse gases, but it's much more complicated in terms of technology. And finally, direct recycling. When the battery cell is discharged and then physically disassembled so that most components can be reused. The problem is that this is very time-consuming. And besides, there are different types of batteries that are manufactured using different chemicals, and those batteries often are not labeled. And this is because batteries were not designed with recycling in mind. And so the workers who take them apart, they don't know in advance what they're going to find and whether the components of this particular battery can be reused. There is also another issue when it comes to recycling, the cost of recycling. The recycling may not be financially viable. First, batteries, including all of the components, are considered universal waste and must be shipped in special containers as hazardous materials, which is very expensive. And second, raw materials may also drop in price, not just increase, but also drop. For example, between May of 2022 and September of 2023, the price of cobalt dropped from 40 to $16 per pound. Now, given the cost of recycling, it is just not worth it at this point. So in conclusion, electric vehicles developers and manufacturers have been trying, fairly successfully, to convince the public that their product is good for the world. But I think that this is just another gimmick that's designed to make a handful of people obscenely rich. The best alternative to conventional cars is still a well-developed, robust, and affordable public transportation infrastructure. But this is a topic for another presentation. Thank you.